Good morning, students. In today's video we are going to cover these isostatic effects. Okay, sorry. So let's start. Isostatic effects of deposition and erosion. So deposition means in some land some deposits are there. It can be any rocks or sediments, etc. Erosion means they go away. When heavy sediments accumulate, their weight pushes the crust downward. When erosion removes material, the crust rises and rebounds. So this is a very simple statement, simple like basic common sense. If you put an heavy object on the land, okay, on the lithosphere, on the crust, so it will it will bend. Okay, when you remove those sediments or deposits, it will again like in the rebounds, okay, or the rises. Like an iceberg floating in water, Earth's lithosphere floats on the asthenosphere. Adding weight makes it sink. Removing weight makes it rise. So what happens is, like the icebergs, they are floating in the water. Okay, Earth's lithos means think of it like this, like icebergs are floating on water and the Earth's lithosphere is floating on the asthenosphere, which is where means fluid like and made up of soft material. Adding weight makes it sink. So adding weight to the lithosphere makes it sink into the asthenosphere, and like vice versa. Many rocks seen at the surface today were once deeply buried but rose due to the isostatic rebound after erosion removed overlying layers. So what happens is many rocks that we see on the surface today was once buried under the earth, under the earth's surface, and but it rose because of the erosion take away the upper layers, and because of that the lower buried rocks rise upwards. So very basic definite means lines statements. I hope you find no difficulty in it. So plate tectonics, isostatic effects. So when continents collide, the crust thickens and much of it actually moves downward instead of only rising. So what happens is, here is the crust. Okay, these continents, these you can see the parts of the blocks of crust. Okay, or you can say different continents when they collide. So what happens? This area rises, the area where they collide, that area rises. Okay, and some of the part moves down. Okay, so in this line it says that not only like rising thing happens, but at the same time this downward thing also happens. Mountains form from the upper parts of this thickened crust, not just from the upward pushing. So mountains of course form, and mountains form also from this downward pushing. Why? Because we know that the mountains have deep roots, and because of these deep roots, mountains height, because mountains able to balance their height. Okay, because of these deep roots. Some collision zones are complex and may not be in perfect isostatic balance. So some at like some you can say places, this collision are way more complex. You just can't fit in everything into these above scenarios. Okay. Ice sheets. So ice sheets in isostatic effects. So ice sheets add massive weight, causing the crust to sink. When the ice melts, the land slowly rebounds upward. So this is called post glacial rebound. So this is same what happens with the ice sheets, like nothing different. Areas like Baltic Sea and Hudson Bay are still rising thousands of years after the last ice age. So what happens in the ice age? When the ice age comes, so the ice started, like the water started to freeze, okay, because of that the crust moved downwards. But at the end of the ice age, the water melts and the crust move upwards. So the after the last ice age, crust it crust is still rising today in these areas like the Baltic Sea and the Hudson Bay. This rebound also causes horizontal shifts, change in gravity, Earth's rotation, polar movement, and can trigger earthquakes. So these rebound, you know, causes the horizontal shifts, okay, and the change in Earth's gravity, Earth's rotation, polar movement, everything, okay. So sea level changes. So now we will see the sea level changes, like what happens to the sea. Okay, we have talked about what happens to the crust, the lithosphere, but now we are talking about the sea. So basically these two things happens with the sea: usostatic change and isostatic change, that we will discover means cover later. Let's start with the eustatic change, global sea level change, okay. Eustatic change occurs when the total amount of water in the ocean changes, or when the shape size of ocean basins changes. So this is the global. First thing to note here is it is global level change, okay. Okay, so the total amount of water present in the ocean changes along with the ocean basin, okay. Just a minute. This affects sea level worldwide, and the causes of eustatic um, change, ice ages, and temperature changes. At the start of ice age, temperature drop, more water freeze into glaciers, sea level falls. So sea level falls because most of the water converted into the ice. Okay, okay. At the end of the ice age, ice melts, water returns to oceans, and sea level rises. Okay, so what happens at the end of the ice age? The ice melts. Okay, of course, it is the end of the ice age. So, name suggests itself. Water returns to the oceans and again the sea level rises. Even outside sea ice ages, global warming can melt sheets ice sheets, sea level rises or increases. So I hope this is quite easy phenomena. Change in ocean basin size. So the ocean basin, I hope you are able to understand the ocean bed. Tectonic movement. So if ocean basins become larger, they can hold more water and the sea level falls. So the ocean basin becomes larger and the total amount of water present in it goes down because the basin becomes larger. If ocean basins become smaller, they hold less water and the sea level rises, okay. So they push the water, because of that water rises. This means this is how you can think of it. Isostatic change, local sea level change. So we covered the eustatic, in that global sea level change happens, and in isostatic, local sea level change happens. So isostatic change happens when land itself rises or sinks, causing local sea level changes. So here what happens? The land rises or sink. Okay. Here the amount of water in the ocean is changing. Okay. Here what happens? land rises or sink. So if the land rises, sea level appears to fall. So you can think of it like this: this is the land, and here is the sea. Okay, so if the land rises, means this land rises. So this sea level appears to fall. Sea level is not falling literally. Okay, it appears to fall because the land rises. And why the land rises? Because of the isostatic rebound. Maybe um, some erosion happens, you know, because of that land rises. And say, you can think the opposite: in the land sinks, what happens is sea level appears to rise. So what happens is, this is the land and here is the land. Okay, and sea level appears to rise. So you can see from here that the sea level appears to rise. Okay, so causes of isostatic change. So ice age effects and tectonic uplift or sinking. So when glaciers form, huge amount of ice pile up on land. Land becomes heavier and sinks slightly. Local sea level rises. Compression. So when the glacier forms, what happens is, huge amount of ice pile up on the land, and because of that, of course, land becomes heavier and sinks. When ice melts, weight is removed, land slowly rises back up, and local sea level falls. Isostatic rebound. This rebound is very slow and is still happening today in some regions. So it doesn't happen. You cannot means it doesn't happen like this. Like one day, like land sinks, another day the land, another like few days or few months or few years, the land rises. No, it takes decades sometimes to a land to rise again. Tectonic uplift or sinking. So land can rise, uplift or sink depression due to these tectonic plate movements. So this type of isostatic change occurs mainly near plate boundaries and affects only specific regions. Okay. So the features of sea level change. So now let's see the features of sea level changes. So we have seen like several sea level changes, like the eustatic and isostatic. Now we will see the features. So features are mainly divided into two parts again: emergent and the submergent. So in the emergent, something is emerging. So emergent landform, so emerging, rising land. Submergent landform, submerging, sinking land. So the emergent landforms, so these landforms appear above present sea level because land rose faster than the sea. So in this emergent landforms, the landforms appear above present sea level because land rose faster than the sea. So means, as the name suggests, you can see like emergent landform. What can you expect from the name? That something is emerging, and here we are talking about the land. So land is emerging or rising faster than the sea. This usually happens during the isostatic rebound at the end of an ice age. So at the end of the ice age, what happens is, the ice melts. Okay, so the pressure on the land decreases, because of that land rises. Okay, isostatic rebound happens. When glacier melts the land, this is what is this written here. Is the example here given is raised beach. So a raised beach is an old beach or wave cut platform now lying well above the current sea level. Behind it, you may find old cliffs with features like wave cut notches, arcs, stacks, stumps. These features were once at sea level but now higher because the land has risen. Okay, So these features were once at sea level but now higher because the land has risen. um, this is what I have explained earlier. The important point here to note is that these emergent features no longer experience coastal erosions. Why? Because since waves cannot reach them now, because they are way more high than the current sea level. So that's why the wave didn't reach them and there's no coastal erosion happen. Instead, they undergo weathering, chemical, physical, biological weathering. Okay, so I hope you are quite familiar of this term weathering. Submergent landforms. So here something is submerging or sinking, and as the name suggests, land. Submergent landform form when sea level rises faster than the land can rise. Okay, as a result, the sea floods the land, especially river valleys and glacial valleys. So here are some examples. The first example is Ria. So a Ria is a flooded river valley caused by rising sea levels. It looks just like normal river valley but filled with much water. Even the flood plain gets submerged, so the cross section becomes wider and deeper. So what happens? It is a valley, okay, and it is flooded with the water, and the floodplains means the land near the valley also submerged and sink into the water. Now next example is F-zode. I don't know how to pronounce it accurately, so excuse me for that. F-zode is a flooded glacial valley, much deeper, steeper and narrower than a ria. It has a U-shaped profile because glaciers carved it. F-zodes are very deep inside but have a shallow entrance threshold where the glacier deposited sediment. So it is an example of glacial valley. So it's flooded with water when the glaciers melts. Okay, and it is much deeper, steeper than the ria. Okay, now let's talk about the Dalmatian coastline. So forms an area where parallel valleys, often old glacial valleys, exist. When sea level rises, the valleys flood, but the tops of ridges remain above water, appearing as long narrow islands parallel to the coast. And the best example of this is Dalmatian coast of Croatia. So you can see it online that the that the land is much above than the sea level. Okay, and forms an area where parallel valleys, often the old glacial valleys, exist. And when sea level rises, the valleys flood, but the top of the ridges remain above water. So yeah, here you can see the top of the ridges are very means much higher than the sea level, so they are not affected by the sea level at all. So these are some examples of submergent landforms. So today's homework is to make an image in your mind explaining this concept. So we have covered so many topics today, like sea level changes, means all are. Uh, we can put all of these subtopics into this one topic, that is isostatic effects. Okay, so isostatic effects, in which we have studied the deposition and erosion, what they do with the land, plate tectonics, ice sheets, and sea level changes like eustatic, that is global level, isostatic local level, features of the sea level changes like emergent landforms and submergent landforms. So what you have to do is to simply draw a flow chart or an image in your mind, okay, and just this way you will be able to connect the topics as well as learn them and retain them for a longer period of time. So with this, thanks, that's it for this video. Thanks for watching.